Here's a very brief review of quadratic functions, parabolas, and a very essential technique, completing the square. We have this quadratic function. Y is a quadratic function of x squared minus 8x plus 12, and we'd like to, basically the task is graph by hand. And whenever that's the task, the idea is not just because we pretend calculators don't exist, it's that we really want to understand what's going on with the function. And the most important point on a parabola, because that's going to be the graph of this thing, is the vertex. For a parabola that's opening upward, this one's opening upward because this coefficient here is positive. It's a 1. Okay, so the vertex is also the minimum value we'd ever get out of this function. And that's obviously an interesting thing about that. Okay, so how do we do that? There's a few techniques, but I want to really highlight the technique of completing the square because it's the most powerful and flexible one. So we're going to look at this, and I want to emphasize completing the square in a way that may be a little different from what you've seen. Often people do completing the square where we look at a whole equation and look at both sides of an equation, but it's really important that completing the square just works on an expression, just this side, just this expression here. And we're just going to take that and we're going to rewrite it progressively in a way that only mentions x once. Okay, I'm going to go through this pretty quickly because it's supposed to be a short video. So the key is that this can be written as x minus something squared plus something else. How would that match? How could that work? Well, the x squared is going to give us this. And then x minus something squared, okay, x minus a number squared, is going to give us x squared minus 2 times x times this number. Okay, that actually is going to match. 2 times x times a number, that could match minus 8x if this number is chosen to be 4. So the minus 8, we divide by 2, and we get a minus 4. That's the thing to memorize. The only thing you really have to memorize is divide that coefficient. In this case, it was a minus 8 by 2. Okay? And in general, it's just going to be the coefficient there. Now, there's some other subtleties that can happen, but that's the main thing you need to memorize. Okay, so actually, let me just continue this. Okay. Now, what do I need to fill in here? Well, let's see. What I usually do is I just imagine maybe we're so lucky is that that's it. Let's just go ahead and test out. So here we go. You don't have to do this, but it's good if you're rusty on completing the square. Well, what would x minus 4 squared be anyway? Completing the square absolutely rests on being confident with the formula for the square. So a plus b, quantity squared, is a squared plus 2ab plus b squared. Gotta be confident with that, or completing the square is going to make no sense to you. In this case, x minus 4 squared would be x squared minus 8x plus 16. So what this puts in is the square of the number we just wrote down, the minus 4. That's not equal to this guy. How do we fix it? Well, what I do is I just fix it in 2 stages. First, I just say, what did we put in that wasn't there, and kill it off. So this has a 16 in it, and you just kill it. Now, this expression is exactly matching the first 2 parts here, and then I just go ahead and say, oh wait, I forgot to match the 12. Okay. So this whole thing, the first 2 terms match x squared minus 8x, and then just the 12 was already sitting there, so I just have to put it in. Now I just combine. And so that's x minus 4 squared minus 4. So that's not the most complicated example of completing the square. We're going to have to review what happens when there's a coefficient in front of the x squared, but that's an example of it. So how does that help us? It means that this is, okay, so let me just put it down here. So there's my expression. It's my equation. So that's the function in a slightly different form, and what this means is that it's the standard y equals x squared parabola shifted to the right by 4 because I put in an x minus 4, and down by 4 because the y values have 4 subtracted them as well. So this is where the transformations of equations like we did with sine and cosine and stuff comes in. And of course the first place you ever did that was with parabolas, so this is definitely a review. Okay, so in other words, the vertex is going to be at 4 minus 4, because I'm taking the vertex of the standard guy, which is 0, 0, the origin, shifting it to the right 4, and down by 4. And so the graph that we get, I'll let the calculator or the computer just do that for me. The graph that we get looks like this. There's the vertex. Now let's just change the limits on that a little bit. Let's just go from, let's say, -1 to 10. So there we go. It's a little more centered. So here's -4, 4 comma -4, and here's the graph. Now the intercepts are often, those are things we would want to plot as well, but we know how to do that. We know to solve y equals 0 here. We know set x equals 0 here, so I won't review that. Now the next thing where we're going to go with this is, what if we have an equation like x equals y squared? That's not y as a function of x. It's not even going to satisfy the vertical line test. So, what's happened is that the roles of x and y have been switched. Instead of y equals x squared, it's x equals y squared. That is a sideways opening parabola. Now it's x. One way to easily remember which way it's going is you just look for the quantity that's either always positive or always negative. The square of any number is never ever negative, and that's why we don't get any x negative over here. X is always going to be positive. And so x equals y squared is going to be a right-hand opening parabola. If it was x equals minus y squared, it would flip over to here. You're going to have a problem where you have to match some parabolas, left, right, up, down, to formulas. And one thing you're just going to need to do is look, is it x equals y squared or y equals x squared? Is it plus or minus? And then maybe just match a few points by actually plugging in some numbers to see what happens. Because one thing we could do, let me add in another graph here. We could add in maybe x equals 4y squared. That's going to make the x's larger for a given y. So think about it for a sec, what that's going to do. If the x is larger for a given y, is it going to get narrower or wider? Well, let's see. We're going to get a narrower parabola. This is the new one here. And so here's x equals y squared, and then here, for a given y value, I go farther over, like y equals 1 gives me x equals 4, because that was x equals 4y squared. Okay.